Okay, last problem, 35. Chebyshev's inequality. And that says that at least what is it? 1 minus 1 over k squared times 100%. That times 100% of the data lies within k standard deviations of the mean for any distribution. Okay, so the empirical rule, the one we just did, was for bell-shaped curves, but this is true for any distribution. So in December 2010, the average price of regulated gasoline was 3.06 per gallon. Assume the standard deviation is 0.06. What minimum percentage of gasoline stations, so all the stations, had prices within 3 standard deviations? So in other words, what minimum? So at least what percent? Okay, at least what percent? Well, it's this guy right here. So A. So at least 1 minus 1 over 3 squared times 100%. At least this percent of gas stations had prices within 3 standard deviations of the mean. So let's do that calculation. 1 minus 1 over 3 times 3 is 9 times 100%, which is 1 minus 1 ninth, so that's 9 ninths minus 1 ninth times 100, which is 8 over 9 times 100. So on my calculator, that's 8 divided by 9 times 100 to convert that decimal to a percent. So that's 88.9%. So at least 88.9% of gas stations had prices within 3 standard deviations. Does that make sense? Okay, now if it was bell-shaped, that'd be 99.7, right? Approximately. But since it's any distribution, that's as good as we can get. What minimum percentage of gas stations had prices within 2.5 standard deviations? Okay. At least, see, I just like to write it out so I keep it straight in context. 1 minus 1 over 2.5 squared times 100% had prices within 2.5 standard deviations of the mean. Well, what is that? 1 minus, well, let's do 1 divided by 2.5. 1 divided by 2.5 squared. It does order of operations. It'll square it first. 0.16. And I'm going to do 1 minus second answer. I'm doing that to show it you can do that. 0.84 times 100, which we know moves the decimal over 2 places. 84. So that's 84%. Okay, so there's B. And then C, what is the minimum percentage of gasolines that had prices between this? Oh, so now we're going backwards. So how are we going to handle going backwards? Okay, so this is a little bit trickier, that we go from 294 to 318. And I know the average, what did we say the average was? 3.06. That was the average, and the standard deviation was 0.06. So if you recognize this, you go, oh, 3.06, how far up and down did I go? I went 3.06. One standard deviation is 312, $3. Another standard deviation is 318 to 294. So that's two standard deviations up and down, right? Okay, so I went two standard deviations above and below. So what's the minimum percentage for two standard deviations above and below? 1 minus 1 over 2 squared times 100%. 1 minus 1/4. And 1 minus a quarter is, of course, 0.75, which is 75%. Okay, so there you have it.